So welcome to the new video. Today's question is find peak element. A peak element is an element that is strictly greater than its neighbors. Given a zero indexed integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums of -1 equals to nums n equals to minus infinity. Means the indexes before 0 and after n minus 1 are minus infinity. We have to imagine this. In other words, an element is always considered to be strictly greater than a neighbor that is outside that array, because -1 and index n are outside the array. So we are considering it minus infinity, so that every element is always considered to be strictly greater than these. So you must write an algorithm that runs in big of log n time. What is the solution that is big of n time? Linear search type. We will traverse linearly. So we will see example how the peak element are considered. For example, 1 2 3 1. So what can you say about the peak element? We can see that 3 is strictly greater than its neighbors, like 2 or 1. Similarly here 2 is greater than 1 and 1, or similarly 6 is greater than 5 and 4. So we will take an example and do a dry run. Let's take an example, like we can take 1 2 3 4 5 7 6 6 5 we can take like 13, then we can take 10 9 8 7, and this is like increasing then decreasing. Okay, so we can say that some part is sorted and some is not. Like this is ascending order, this is descending order. Let's find linearly. First of all, 0 1 2 3 4 5 6 7 8 9 10. These are the indexes. So let's start from here. How we'll check it is peak element? We will imagine minus infinity and minus infinity here. So is 1 greater than minus infinity? Yes. Greater than 2? No. Move here. Is 2 greater than 1? Less than 3? Greater than 3? No. 3? No. 4? No. 5? No. 13? Yes, it is greater than 5 and greater than 10. This is the peak element, we can say. So what will the approach? And see, these are the extra condition. We will say edge cases, because our index, we cannot say index -1. Suppose this is, you are saying I. So I minus 1 is here, -1 on this index. For this index, I plus 1 is, this is greater than n minus 1. So it will get out of bound. So for preventing it to get out of bound, what we can do, we can take this as extra conditions. We can take this as extra conditions. Suppose if I equals to 0 and array of I, suppose we are talking of this, and array of I is greater than array of I plus 1, then what we can say, return I. Similarly, if I equal to n minus 1 and then array of I is greater than array of I minus 1, then we can also return I. Similarly, if array of I greater than array of I plus 1 and then array of I is greater than array of I minus 1, then also we can say return I. And outside is a for loop from 0 to 1. I equals to 0 to n minus 1. Also, we can merge these all else if into one. How? Suppose you are saying if I equal to 0, if I equal to 0, what must be the end case? What is the end case? Array of I should be um, greater than array of I plus 1. See, I am merging these two conditions. You are seeing the if. I hope you understood that we are merging these condition. These two, if I equals to 0, we are writing this condition and I greater than I plus 1. Now also or condition, what can be happen, that or is that I is n minus 1. Suppose first of all this condition is, or what can happen, or it might be possible that or both, we will let or in both the cases greater than I array of I minus 1. I is greater than n I minus 1 array, wait a minute, yeah, array of I is greater than array of, oh sorry, or what can be possible for n minus 1, we have to write because it is left. So if this is possible, if is there, all the three conditions are valid here in this if. I will show how. See, wait a minute, just yes, see now all the three conditions are valid. I have checked that if I equal to 0 and I is array of I is greater than I plus 1. See here, I is equal to 0, and because this is in the bracket, this is the bracket, you can write that this is a bracket. Okay, this is how it is working. Now I equal to n minus 1, I is equal to n minus 1, and I is greater than I minus 1. See, I equals to greater than equals to n minus 1, and because end is here, so this end will work. I is greater than n I minus 1, and similarly these both at end condition, this and this. So it is working in one if only, return I. So you can write a for loop using this, and it will pass. It is the brute force solution. Now what is big of log n solution? Let's see big of log n solution. How we will think that binary search can be applied here, because these, see, some part is sorted here when a peak is there, some part is sorted, some part is descending sorted, and there is a peak. And suppose now for binary search we have three things: low, mid, and high. Suppose mid is here, one case is this. When mid is here, where is the peak? Peak is here on the right, and see, mid is on the increasing slope. See, you can see increasing slope. So I can say mid minus 1. This is mid minus 1. See, what are the three cases? First case is this: mid can lie here, peak can be on its right. Second case is mid can be here, peak is on the left. Third case is mid is this only. Now see, if mid is on increasing slope, this is the increasing slope. So what can we say, that how to check that it is increasing slope? We'll write array of mid is less than array of mid. Then we will say, we will eliminate the left part because peak is on the right part. We'll say low equals to mid plus 1. Now see here, mid is on the left. what we can say, array of mid is less than array of mid minus 1. Then we can say eliminate the high part because peak is on the left part of the array, so mid minus 1. Similarly, if the mid is only the peak element, how we will check? Simply we will check mid minus 1, array of mid minus 1, and array of mid is greater than mid minus 1, and then array of mid is greater than array of mid plus 1. These are the three cases. Now, will it work from multiple peaks? Because in question we have multiple peaks. Let's see here. 1, 2, 3. We can have multiple peaks, like an array 1, 2, 3. Then we got 5. Then 4, 3, 2, 1. Then again we can get 7, 8, 9. Then again 13, 11, 12, 11, 10. Again we can get 15. Then we can get 14. This is the example of multiple peaks. So see, 5 is also a peak in itself. 15 is also a peak. 13 is also a peak. There are multiple peaks in this. So will it work? Yes. How it will work? Suppose mid is here initially. If mid is here, we will say it is on increasing slope. Eliminate the left part. Peak is on the right. See, peak is on the right. We will get, if mid is here, we will say eliminate the right part. We will get a peak still. Still we will get a peak index. And if mid is here, suppose, then we can say, we will write this case extra. If mid is suppose here on the lowest point, it is like a trough in the crest, so it is a crest. Sorry, peak opposite is this. This is the lowest point. So we have to write this case. This is the extra case. When mid lie here, it is neither greater than this. It is neither on the left slope, increasing slope or decreasing slope. So what is this? We'll write it as else condition. Else condition, that we can either eliminate this part or either eliminate this part, because either way is the peak line on either side. So we can do anything, either do low equals to mid plus 1 or do either high equals to mid minus 1. Either work, both ways will work. You can write either condition. So I think you understood the question, how to solve this. Let's write the code and understand it more properly. Let's take low index to be 0, high index to be, let's take an n equals to nums dot size. And yeah, there is one more case, which is an edge case. Suppose 1, 2, 3, 4, 5, 6. So for this, for the 0th and the 5th index, we have to make extra condition. So we will write a separate condition for this initially, like if I could go to 0, what we can do, we can check array I also if there is one element, only in the array. If n equals to 1, we will just return that element, return array of 0. Okay, this is one or more case, because if one element is there, side is minus infinity, this is always the peak. This is a one case. Another case is for I equal to 0, we can say if array of I is greater than array of I plus 1, Then we will just return array of 0 or 0 index. We have to return index actually. Return index. Similarly, for I equal to n minus 1, we'll say array of I greater than array of I minus 1. Return I. Then we will start our low pointer and end pointer from 1 and n minus 2. Now we can start our loop. So initially, wait a minute. Yeah. If n equal to 1, return 0, high equals to n minus 2, low equals to 1, and start the while loop. Low less than equal to high. What is the mid? Mid is like always high plus, sorry, low plus high by 2 actually. High minus low by 2. And if what the condition is this, what is this condition? If array of I is greater than, actually it is not array, it is nums vector. So if it is greater than I plus 1 and nums of I minus I 1 is less than nums of I, just return I. Else if nums of mid minus 1, actually this is not I, this is mid. Similarly, this is also mid. Mid minus 1 is less than nums of mid. This means increasing slope. So what to do in increasing slope? We will eliminate the left part because peak is on the right part. We'll do mid plus 1. Else if nums of mid plus 1 is greater than nums of mid, this means mid minus 1 is less than, mid plus 1 is less than, mid plus 1 is less than nums of mid. This means decreasing slope. So we'll do I equals to, because peak exists on the left part now. Else what we have to do, if suppose neither this condition, neither this, that means we are on the lowest point, minima, local minima we can say. So what to do on that part? We can do either low equals to this or either high equals to this. Let's do low equals to mid plus 1. Now just return minus 1 because it is a int. This will give the answer. Return I, return mid actually, not I. Let's submit it, compile it first of all. Yeah, compilation done successfully. Now let's submit this. And there is one wrong answer, which is output is this. Let me check what's the problem. Okay, actually I have not written two conditions. See what I was talking about, I have not written that condition. Edge cases, if I equal to suppose if array consists of two elements and we are on this for nums of 0 greater than nums of 1, return 0. If nums of n minus 1 is greater than nums of n minus 2, return n minus 1. I think now this test case should be running. Yeah, submit this. Submit it. Okay, so I hope you understood the question. We will meet in the next video. Till then, goodbye.